LeetCode 121. Best time to buy and sell stock might sound like a simple profit puzzle, but it's really about smart, scalable decision-making. Think real-time trading systems, where you're crunching data non-stop to buy low, sell high, instantly. With huge input sizes, brute force isn't just slow, it's unusable. So the real challenge here? Spot the best deal fast. Let's break it down. Let's kick things off with a classic brute force move. We'll march through every combo of buy and sell days, hunting for the highest profit. To begin, we set up a variable to hold the best profit we've seen so far. Since we haven't bought or sold yet, we start at 0. We drop in our outer loop to treat each index as a possible buy day, stepping through the price list one by one. Inside that, we nest a loop to scan all future days as potential sell points, making sure we never sell before we buy. On each pair, we calculate profit by subtracting the buy price from the sell price, capturing the gain from that transaction. If this profit beats what we've seen before, we update our tracker. This way, we're always keeping the best deal in sight. After checking all valid buy-sell combos, we drop out and return the max profit. If nothing ever went up, it'll still be 0. That gives us big O of n squared time, up to 100 million checks for 10,000 prices. Space stays constant, but the runtime, not scalable. So how do we cut the waste? Instead of comparing every pair, what if we already knew the lowest price before each day? One scan per day, no repeats. We start by grabbing the array length, useful for both prefix setup and our final scan. To track running minimums, we'll build a prefix array. Each slot stores the lowest price we've seen so far, up to that point. We kick off by setting the first prefix value to the price on day 0. Nothing comes before it. From there, we fill the rest of the prefix array, taking the lower of the current price or the prior minimum day by day. Once the prefix is ready, we set up a result variable to hold our best profit, just like before. We scan from day 1 onward, comparing today's price against the lowest so far from the prefix, and updating our best profit when we see a gain. After the loop, we hand back the highest profit we found. No gains? No problem. It'll naturally return 0. This method runs in big O of n time, 2 clean passes. But now we're using big O of n space for the prefix array. Clear logic, but heavier on memory. Can we streamline that? If we skip the prefix array and track the minimum in real time, we can keep things lean and fast. We set up 2 variables, one for the lowest price we've seen and one for the best profit so far. Then we scan the array, treating each price as a possible sell moment. If today's price beats our current low, we've found a better buy, so we update our minimum. Otherwise, we check if selling today gives us a better profit. If it does, we lock it in. After processing every price, we return the best profit found. If prices only dropped, we're still safe with 0. This version runs in big O of n time, just 1 loop. And space? Big O of 1. No arrays, no overhead, ideal for both interviews and production code. We started with brute force, checking every combo, but paying a steep runtime price. Then we sharpened our edge with a prefix array, cutting time but adding space. Finally, we nailed it with a single pass, constant space solution, tracking just what matters, the lowest buy and highest gain. This isn't just a coding win, it's a real-world strategy. Spot trends, filter noise, act fast. If you're prepping for interviews, this is gold. And if you're building for scale, even better. Now ask yourself, where else can this trick unlock performance? Keep coding and keep quacking forward.